Okay, welcome to the session 7. So in this session, we'll be discussing on these three topics, that is operators in Java, the control statements in Java, and arrays in Java programming. So if I talk about operators in Java programming, so if you are familiar with the operators with C and C++, as I told, it should be a prerequisite to you whenever you want to learn a Java programming. If you know or if you're aware about C and C++ programming, Java programming becomes easier for you. Hence, with assumption that you are aware of operators in C and C++, and if I talk about operators in Java, both are almost similar. So that is, operators are divided into four categories: arithmetic operators, bitwise operator, relational operator, and logical operators. Fine, that's the same way what the C and C++ has. Hence, I'm not going to discuss much about operators in this session, but I will just highlight the points where exactly the Java has enhanced its operators performance or operators inclusion to improve the performance of its Java programming. And so now when I talk about arithmetic operator, you know what are the list of arithmetic operators, and now the arithmetic operators whatever we have used until now. So we were using it on all the integer type, it can be used on the floating point types, even this can be used on the characters also. And as the new type has been introduced in Java program, so make a note that the arithmetic operators cannot be used with the Boolean types. And this is the one note you need to make it out. And the second is the modulus operator, what we have came across until now in the arithmetic operators. The modulus operator was used only with an integer data types. It can be short, it can be the hint, it can be the long, but modulus operator was not made to use with the floating point numbers if it is C and C++. But in Java program you can use the modulus operator even for the floating point numbers also. Hence, make a note of this also. And the next important distinction what it makes from other operator programming languages, now we are going to have a right shift operator. When I'm going to talk about bitwise operator, right shift operator is part of bitwise operation or operator. So now right shift operator has got one more variation in your Java program, which we call this as unsigned right shift. And I just noted about this, I just highlighted about this unsigned right shift when I was discussing about typecasting. I'm discussing about the typecasting conversion from one type to another type in the previous session of our lecture video discussion. I just told you that whenever we need to maintain the higher order bit, Java is going to make it in a different way. That is what the Java is going to do using an unsigned right shift operator. If it is a right shift operator, the number of bits will be keep on shifting towards right hand side, that is towards lower order bit, by filling the left order bits or the right order bits with zeros. It's going to just shift the bit content whatever it is towards right, and whenever the bits are vacant towards left hand side, all those will be filled with zeros. And so if I'm going to use unsigned right shift, so whenever the shift is going to happen, remember this, the previous bit content will be replaced, not zeros now. If it is right shift, irrespective of what the previous content is going to be, it's going to be filled with zeros only. But whereas in unsigned right shift, it's going to fill with the previous bit content. And so this will preserve the signed content of any value. If it is 1, it preserves it as 1. If it is 0, it preserves it as 0. If it is negative value, it preserves it as negative value. If it is positive, it preserves it as positive value. So this is where it's going to make use of unsigned right shift. Hence, and this is the operator what you're going to use. If I just use this 2 greater than symbol, this is going to be a right shift operator. And if I use the same with 3 combination or 3 characters of the same, this is going to be an unsigned shift right shift operator. And with this, the next important changes, when I talk about logical operator, there are only logical operators, that is we say it as AND operation, OR operation, and so on. But in Java, there is a category called as Boolean logical operators. So the logical operators, what we are using and or, so we are going to know it as Boolean logical operator. That is, for this variable, if you are going to pass operands as integer, or if any one operand is an integer, now this will be treated as a bitwise OR operation. Even similar with this, if any one operand or if both the operands is going to be an integer data or a floating point data, it is going to be treated as an bitwise operators, bitwise OR operator and bitwise AND operator. Now the same character has been defined with an additional responsibility. Now if the two operands is going to be of Boolean type, whenever the two operands is going to be of a Boolean type, in that case this will be treated as Boolean logical operator, that is OR operation. Now no more bit operation will be performed, only the logical operation will be performed, true or true, true and false, and so on. Similarly with this, hence we call this as Boolean logical operator. Fine. So now you might have used these operators at this point of time in C program or C++ program whenever I want to combine a compound conditional statements. And so now this operators, now we are going in Java, we are going to call this as shortcut operators. The reason why we call this as shortcut operator is, just look at this example now. Now when I say if A equals 1, I am going to have and B less than 2. So let's look at this. Now the output of this is going to be either true or false, that is a Boolean value. Again the output of this is going to be a Boolean value. Hence the relational operator will always return me a Boolean value. Hence now both the operands are Boolean. Hence in this case we are going to use the Boolean logical operator, and hence now this will be treated as a Boolean logical operator. If this were just integers 1 and 2, if it were 1 and 2, then this would have been treated as bitwise AND operation. And now, so with this, so next we are going to have for this, as I told, short circuit operator. Just look at this example now. In this example, if this condition is true, even I need to check this condition also. Hence, because if this condition was to true, I need to check both the condition if it is true or not. So to say the AND operation will give me the result as true when both the conditions or both the operands should be true. Now what is the other case? What if this is false? If this is false, irrespective of what is this, even if it is true, even it is false, this will stay, the whole condition will still say. So now just look at this example now. In this example, I'm using an OR operation. Now if this condition is true, I need not check this condition. Irrespective of what this value is going to be, this entire condition is going to stay true, or an entire condition is going to stay false. And so now in this case, when this condition is false, I need not check for this condition. In this case, if this is true, I need not check for this condition. Hence, so now once I am able to derive the answer at the off execution of the statement itself, I need not worry about the remaining part. And that is what we call this as shortcut. I'm using the shortcut method to know what is the condition answer is going to be. That is what the shortcut operator is going to do in your Java program, or mostly it will, the same thing happens in any other program language, but nobody had given a technical name for that, but Java has done that to do. Fine, this is the operators of Java. Fine. So next we will see the control statements in Java. And as we have seen, when I say control statements, it is how you are going to control the execution line of your program. And so now the execution line of your program can be controlled in two ways, either using selection control, or using iterative or iteration control, or using the jump control. And so now if I talk about selection, and you are already aware of this, It is something what we do using if statement or if else statement or even the switch statement. That is where the selection statement is going to work. And if I talk about iteration, that is I'm just going to have a loop, any kind of loop, the while loop, the for loop, the do while loop. This will be treated as an iterative or iteration statement. If I talk about jump, so in C program you might have came across the go to statement, or you might have came across the break, the continue, the return, the exit. All this is going to be an jump control statements. Hence you're already aware of all these statements, how a if works, how a switch works, and how the loop works, and how the go to works. But we will just try to, at the abstract level, we'll just try to focus on in what way this is going to be different in Java programming. Hence we'll discuss about the selection, iteration, and the jump. If I talk about selection, it is all same. You know about if statement, how it works and how to use the if else, if else if else ladder, the nested if, the switch statement, as well as nested switch statement. So you are already aware of how this is going to work, hence I'm not going to stress much about this discussion. And if I talk about iteration, again the same three famous loops, the for loop, the while loop, the do while loop. The syntax, the way we use, still it is going to be intact in Java also. And even you are aware of how we're going to work with the nested loop, that is defining a loop inside another loop. But the new thing what the Java has introduced is a new kind of for loop. Fine. This is what now we need to focus upon. This is what we need to discuss and understand how this for each loop is going to work. As we'll just do it in a while. And now if I talk about jump control statements, we know about the break, how the break is going to work, and how the continue is going to work, and how the return is going to work. This is as usual what you learnt in C and C++ program. But the new thing what Java has added is something called as labeled break. That is a variation of a break statement. And Java is going to add a variation for the for loop and a variation for the break statement. We'll see exactly what this two is going to be. But before that, a small information which you should know. So as we know, in Java, as in C++ program, we can define the variable wherever we want. Hence, so whenever we're going to start the loop, I can define an control variable or iteration variable. That is something called as I. I can define the variable here. I can use this in the loop itself. Fine. And if I talk about the comma operator, that is in a loop, if you want multiple assignment statement, you can do using a comma operator. And so I'm going to have int I equals 0, and assuming j has been already defined, I am initializing the value of j. I'm going to have one condition after semicolon, and again semicolon, increment of I, comma, increment of j. Hence we can use the comma in this form. But remember, in C++ program or in C program, we are going to have the comma is going to be like an operator. It is treated as a comma operator. Whereas in Java program, so this comma operator is treated as an separator, just a separator. It is no more an operator. So note it down this point. So comma is just a separator in Java programming, whereas comma is an operator in C and C++ programming. So now we'll just discuss how the for each style of looping is going to work. As I told you, it's a variation of the for loop, what you already learned. And so now if I talk about the for each style of looping, so now this is the loop which we usually use to cycle through set of values. That is, it will start from the first value of the set and it will reach automatically to the end or to the finish of the set. Hence, whenever you want to cycle through set of values, make use of for each loop. And the set should be strictly sequential storage, something like array. That is, we say array is an sequential element, sequential storage, sequential allocation. Hence, so whenever you want to use the for each, loop or for each style of looping, make sure you're going to use it on sequential storage of values. So in C hash, there is such for each style of looping with the keyword for each. So instead of using for as a keyword, a new keyword has been introduced in C hash programming as for each. But whereas in Java programming, it is not going to use any such new keyword. It is going to use the same keyword for without any modification for this keyword. It is going to use the same keyword, and the Java is going to enhance this for keyword to work as in for each style of looping. And so now this, whenever we are going to enhance this for, instead of saying this as an for each loop, we need to call this as enhanced loop, because the same keyword has been enhanced to work in a different way. Hence in Java, remember this, we are not going to use any new keyword called as for each. We are going to use the same keyword even to work as an for each style. Hence, so if I am using this for each style of looping, it will make sure it is going to prevent the array boundary errors, that is out of array bound, usually which you're going to get it as an array bound exception whenever you use the index value which is not applicable. In that case, you're going to end with an array bound errors. Even that can be completely prevented. And as usual in the for loop, the way you use the break statement, even in this for so you can use the break statement. And remember one more important point, iteration variable is read only. Remember this point. In few minutes I will exactly tell with the example what exactly you mean by this. Hence, just look at this example now. Now this is the usual way how we use the for loop. That is, we are going to use the keyword for, and we are going to have three block of statements or three set of statements. First one, usually we call this as initialization. Second is the condition, and the next is the modification. So each separated with semicolon. And I'm going to give set of statements or block of statements. This is as usual for loop what we are using all these days. Now just look at this new type, the for style of looping. Now we are going to use the same keyword for. So now I'm going to have only two parts in the for loop now. Here there are three parts, and now we are going to have only two parts. And one more important thing to note here is I am separating each part here using a semicolon. Now in this case I am separating using a colon. This is the one important change which you need to observe. And I am just going to have again the block of statement. And in this time, in this for loop, when you want to have this part, either you can declare a variable here and you can initialize int I equals 0, something like that, or you might have declared the variable and you going to only initialize here. That is, I am going to say int I somewhere in the program, and in this I will just say I equals 0. In any other way you can do, but whereas in this you need to declare the variable here itself. Hence we are going to have the type, that is the data type, and the iteration variable or iterative variable which you want to use, and the collection. When I say collection, it is the set of values which you need to pass to the loop to start and to finish from the given set. And this is the syntax of using the for loop in a different way. So just observe here, I'm going to have the same keyword now using in two ways. Hence we now call this as enhanced for statement. Fine. So now just look at this example now. Fine. In this example, now I'm using the whole style of for loop. I'm going to define an array, declare array using initialization. Hence I need not give any size for the array right now here. Hence I'm going to have array equals 1 2 3 4 5, and I'm going to have a loop. I'm going to traverse from the 0th index to the 4th index. Hence I'm going to print all the values. So a of 0 is 1, a of 1 is 2, and so I'm going to print all the 5 values from the given set of elements or array of elements. And this is how usually we use. And now look at this example. I'm using the other type of loop. I'm working on the array, which is a sequential storage, hence I can make use of the for each style also. And the same declaration, the for loop int value, that is I am using int here because the array what I am using or the set of values what I am using is going to be of the type integer, hence this should match whatever the set, that is a is going to be the set now. The array name is going to act as a set of values now for me. Hence the array name a what I am using here, this is going to be of the type integer, hence this should match the value. Hence the type is going to be integer, iterative variable name is going to be value followed with a colon, and the collection or the set is going to be the array a. Now this is how I define a for loop. And once I enter the loop, I'm going to, at the first iteration, the first value in the set will be assigned to the value. Hence I'm going to print it as 1. And automatically the second value will be assigned to the value from the cell, that is 2. And I'm going to print 2. When I come back, automatically 3 is assigned. And I'm going to print 3. When I come back, 4 is assigned. Print 4. When I come back, 5 is assigned. I'm going to print 5. And when I come back, I have reached end of the set or the list. I'm going to come out of the for loop. And this is what we say. This for each is going to cycle through set of values from the start to the finish. From the start to the finish. And how this is going to, loop is going to work, as both are similar, both does the same job. But the one advantage here is I'm not going to use any index values here. I'm not using any index values here, as well as I'm not performing any condition operation. I'm not performing any modification, something like increment or decrement operation. Even I'm not doing any indexing over here. This all will be done automatically by your Java compiler. This is the advantage of using for each style. And one more important thing what I just told, it completely prevents boundary errors. So now in this case, for example, what if I'm going to have I is less than 10? What happens when I say I is less than 10? So for a equals 0, the loop works fine. For 1, it works fine until the value of I is 4, it's going to work fine. When the value of I becomes 5, I'm saying a of 5. So what is a of 5? A of 5 doesn't exist. Hence I'm going out of array boundary. And this is going to cause me a runtime error. But whereas in this case, the loop is going to start at the first value and automatically it will stop at the last value of your set of elements what you have passed. This is what is going to prevent the boundary error. And if you want, you can use the break statement in this case, and even in this case also you can use the break statement. Fine. And now just look at this. I just told you that iterative variable, iteration variable is read only. Now I will just see what exactly this is going to mean. So now just look at this example. We are just going to have an array, and I'm using for each style to traverse the array from the first starting to the end, and I'm going to have an iterative variable. I'm assigning each value for its value. So now when I say value equals value into 10, now will this change the value only in this variable, or this is going to change the value in the array itself? Because right now the int value contains the first value of e. So now when I perform this operation, remember this is going to change only in this variable. This operation, execution of this operation will never affect the array elements. That is what we say, the value is only read only. It is just going to read the value from the array. It will never modify the value from the array. Hence for this case, whenever we are going to print this, I am going to print the value as 10, 20, 30, 40, 50 because I am multiplying every value. And again, if I am trying to use the same for each style, and if I try to print the array, you can observe I am going to print 1, 2, 3, 4, 5. That is, the value of array is intact without any modification. This is what we say, the iteration variable is read only of the array elements. Fine. So now just look at this example. This example now, I'm going to have an array and I want to find sum of this array elements. Fine. Hence, this as usual what you're going to do, and at the end we are going to print the sum, the same whole style of for loop what we are going to use. Now I am using the for each style of looping, the same operation, int value a. So without using indexing, without using increment, without using condition, we are performing the same operation. This is the advantage of using for each style. And just look at this example now. Now I'm going to have int sum equals 0, and I'm just trying to find the sum of n natural numbers, that is sum of 5 natural numbers. And so now this is the example. I'm going to add 1 plus 2 plus 3 plus 4 plus 5, and I'm going to print the sum of 5 natural numbers. I'm not using any array concept over here. And so now if in this is the case, now I cannot think of using the for each style of looping now, because in this case we are just going to have only the for loop. So we cannot think of for each life of looping in this case because the array is not involved. And just look at this one more example now where we cannot use the for each style of looping. I am using array. As soon as I use array, it doesn't mean that I can use the for each style of looping. I am going to find the sum, similarly what I am doing here. And now just look at this one modification what I have made. Instead of having I plus plus, I have made I equals I plus 2. That means, so my intention here is to add the sum of odd numbers, or I want to jump. I need to add the first element, then I need to add the element 3, element 5, element 7, and so on. That is odd elements I need to add. In this case, now you cannot think of the for each style of looping, because the for loop will automatically increment to the second element. It will never jump. It is not going to jump. It will start from first element and reach the last element. This is the second scenario where you cannot use the for each style of looping. And clearly understand where we can use and where we are not supposed to use. And so now we will just look at how we are going to use this for each style of looping with the multi-dimension array. Now we have seen how we are going to use this with a single dimension array. Just look at how we are going to use this multi-dimension array. So now I am defining a multi-dimension as int a, where we are going to have 3 elements in the first row, 3 elements in second row, and the 3 elements in the row 3. And so this is going to be 3 cross 3 matrix for me because I am using a 2 dimension. Using the nested for loop, I am going to print all the array elements. This is the same what you are doing until now. And now just look at this example, the way we are going to use the for each style of looping whenever we are going to talk about the for each style and with the multi-dimensional array. In this case, now just look at this. I am just going to use int b. Now just look at, so this is easier to understand for us because this is what I was doing until now using for each. I was using int values, and this values is going to pass an array. Now this should be set of element. So now just observe, a is going to be array of array elements. Hence your for each style of loop will work only on a single array, not on an entire 2 dimension at a time. Hence you need to reduce this, the 2 dimension to be reduced to 1 dimension, and from that 1 dimension I am going to access each value at a time. If it is 3 dimension, from 3 dimension we need to reduce to 2 dimension, from 2 dimension to 1 dimension, and that 1 dimension should be used as in values. So this is how the for each style loop is going to work with multi-dimension. And in this example, just look at this. When I say for int b array, because I'm just making a 2 dimension to be 1 dimension now. In this entire row, this one row of value I'm trying to put into b from 2 dimensional array a. Yes, now this b should be an array now to hold this 3 set of values. Now b is holding a 1 dimensional array of 3 elements 1, 2, 3. Hence this is going to contain set of elements, that is 1, 2, 3. Now 1 will be used, 2 will be used, and 3 will be used. and in the next iteration when I come back, so B will be assigned automatically with the second set of elements, and I'm going to do the same operation. When I come back, the B will be assigned with the third set of statements, and this is how the for each style of looping is going to work with the multi-dimension. Now just look at this one more example now with the multi-dimension where we cannot use this style of strategy. If I use, it's going to be a complicated one. Now for example, I'm going to have a two-dimensional array. The first row contains 2 elements, and the second row contains 3 elements, and the third row contains 1 element. Now this is not the usual type of two-dimension where we are going to have 3 cross 3 or 2 cross 2. If such a case, I can do it so easily. But now there are 3 rows and this loop is going to work fine. But what about this? Now what value this should hold? In the first iteration, this should be 2. The second iteration, it should be 3. In the next iteration, it should be 1. And now how do you control this? So you can use some logic, use some flags, use some variable, you can do this. But this becomes a complicated one. But for the same scenario, look at the for each style of looping, how it's going to be advantageous now. Fine. So now for the same looping, I'm just going to have for each style of looping now. For the same set of elements, I'm going to have 1, 2, 4, 5, 6, 7. And now I'm going to have the same looping what I've done here. So now this is going to work fine, whatever the length of a array is going to be. Because when I assign a set of elements, right now it is 2, the loop is going to work only 2 times because it starts at the first value, it ends at the last value. This works fine. And when I come back, I assign this 3 set of values for the B. Now again this is going to work fine. I'm just going to have the start of 4 and the end at 6, and this loop work for 3 iteration. Come back, it was for 1 iteration. Hence, the for each style loop is going to work fine even in such scenarios where the traditional for looping style may be complex if we try to solve this. Hence, now with this, we'll just move on how we are going to use the break in another form, the second form of break statement, what I called it as label statement. Hence, we are going to use this break statement similar to the go-to statements, what you came across in your C programming or in C++ programming to jump the control from one point to the other point, the forward jump or the backward jump. So similar to that, it's not as same as go-to statement. It has been modified and it has got its purpose. So we'll see how exactly the break will be used as a go-to statement. Hence, we are going to call this as labeled break, because if I just use the break statements, it is as usual break statements which you usually use in a for loop or a while loop or a do while loop or even switch statement. Hence, we use this only in the looping statements or in switch statement. But for the same keyword, if I assign a label, now this becomes a labeled break, and this works now similar to the go-to statement. Hence, we are going to have an example to understand how this is going to work now. So now I'm just going to have 3 labels here. The label is going to point at the block of code. It's going to point at the block of code as the first, second, third, followed with a colon, the similar way what you're doing with the go-to statement. And now I'm going to have a break statement here, and this break statement is going to be with the second, that is the label what I'm going to use here. And just understand, so this labeled break can be used with the for loop or any in looping statements or in switch statement as well as in any block of statement. Remember this. But whereas break should be used only in the 2 places. Either it's going to be in the for loop or in switch case. It is in the looping or in the switch case. Whereas the labeled break can be used anywhere inside block of statement. Remember this. And so now I'm using if statement here. I'm using break. When I say break second, clearly observe when I say break second, if it was go to statements, the control would have been shifted to the label where the second was staying on. The control was supposed to shift here, but the break is not going to do that. Remember this. When I encounter a labeled break, So the control will shift to the end of the block where the label is pointing at. Now this is the starting of the block where the label is pointing at, and this is the end of the block, and the control will going to reach after the statement or at the end of the block. This is how the break label is going to work. If it was a go to and a label, the control would have been shifted to this label and starts execution from here. But whereas there is a break on the labeled break, hence the control will shift to the end of the block of the label what you are given. If this was break first, then this is the block, and this was the end of the block, the control will shifted here. This is second, and the control will shift at this statement. This is how the break label is going to work. Hence, if I execute this program, I am just going to get the output as, first I am going to print it as before the break, and next this condition is going to be true because the boolean variable t is true. This condition becomes true. I am going to break to the second block of statements, and this is the second block of statements. The control will come at the end of this block. Hence, without executing this, directly I will go here and execute. This is after second block. This is how the break statement is going to work. Fine. So now just look at one more example how this break statement should be used and should not be used. So now in this case, I am using the break statement inside an for loop or nested for loops. So whenever we are going to have deeply nested, or when I'm going to have two level of nested statements, now this is the break statement what I'm using as usual, the old version of break. Now just look at this, what happens now. I'm just going to have a for loop here. I'm going to inner for loop here, and I'm going to have break statements. So now what happens when I'm going to have a break statement? It will reach end of the loop. That is, the control will come outside the loop and this will be executed. I will go back and keep on executing. Hence now this is the output what I'm going to get. I'm going to get 0 as the value of the inner for loop, then the value of inner for loop 1, the value of inner for loop 2, and when the value of j becomes 3, break, that is come out of the inner for loop and print the value of I as 0, and go back, increment the value of I to 1, do the same operation and print as 1 and 2, and I'm just going to reach end of the loop. I'm going to print it as end. This is as usual how the nested loop is going to work. And now just look at this example where we are going to use the labeled break here. So now in this labeled break, we are going to have break outer. We're going to have break outer. So now instead of using just break, I'm using it as break outer. So now in this break outer, I'm just going to, when this condition is true, the control will shift to this block. Hence this block is going to end at the statement over here. It's going to end at this statement. It will reach at the end of the block. And so now whenever we are going to reach this break counter, the control will immediately come at this end of the block, end of this block statement. And this is how the break labeled is going to work. And so now for this case, I'm going to get this as output. Just look at this two difference. This break statement will break only the inner loop, and now this break statement is going to break both the inner loop as well as the outer loop. Hence, using the labeled break, you can at a time break any nested loops, which is not possible using a break statement as traditional. Fine. Fine. So now one more example where you are going to see the break statement cannot be used. Fine. Now this is as usual what we are doing in the previous example to break both the nested loops at a time. Just look at this. Now if I try to execute this, I'm going to end with error. The reason why we are going to end with error here is, now just look at this. I'm trying to use the break statement as outer. This is a separate independent block of code, and this is a separate independent block of code. The I for loop is a separate block, J for loop is a separate block. When I say break outer, you're trying to make the control to transfer from one block to another block which are two independent blocks. Hence you're not supposed to do this. You cannot break the control from the independent block to another independent block. Whereas in this case, these were not independent, they were dependent nested blocks. So in the nested blocks, you can use the labeled break, but if it is not a nested blocks, you cannot use the labeled break having the label at a different block and having a break at a different block. Hence for this reason, you are going to get an error. Fine. So now we'll just discuss what is arrays and how exactly arrays should be declared and to be used in Java program. Now just discuss this when I say declaration. So in C and C++ program, so an array is going to be a single step process of declaration, and in Java it's going to be two-step process. So now I'll just tell what exactly this is going to be. When I say array is going to be a single step, it is just as simple as this, what we are doing, int a of 10. And now in Java, when I say two-step process, I'm going to have int a. I'm not going to define any size over here. You're not supposed to define any size for the array. You are in this statement, you are just saying that this variable is going to be an array variable of the type integer. No memory will be allocated at this point of time. And once this is done, now you need to allocate the memory for the array in a separate block of statement like this. That is, a equals new is a keyword which we are going to use for dynamic memory allocation. That is, whatever you have learned about malloc and whatever you have learned about calloc, that is what we are going to talk about the new operator. So new operator is similar to a calloc, so which is going to allocate a memory, or the malloc which is going to allocate the memory dynamically. Hence in this case we are going to have hence in this case we are going to have a equals new int. I am going to allocate 10 blocks of memory for this array, and so this should be done dynamically. I am going to use the variable of the array assignment operator, the new operator, to allocate the memory block. Now how many memory blocks should be assigned and what type of memory block should be assigned. Now this is the syntax and is the example what you're going to use in Java program. Hence that is what we say in Java, it's going to be two-step process. Fine. Now as in this case, when I declare an array, I'm going to have a label for the array, that is as a, and I'm going to allocate 10 blocks of memory, and the index value will start from 0 and ends at 9, and it's going to be filled with garbage values as usual. And once this allocation is done, we are going to allocate or assign the label to this block of memory. This is what happens in one step in your C program. But whereas in Java program, when I create this statement, a will be created and it will be assigned with a null memory address. Hence at this point of time you cannot use this array because array contains 0 memory blocks. Hence you cannot use this. Hence you can use this array block only when you're going to create an integer of 10 blocks in the second statement. When I execute this, the new 10 blocks will be created, and more importantly, initializing every block with 0. In Java, this is what happens, whereas in C and C++, it's going to stay with the garbage value, but now it's going to fill with zeros. And I'm going to assign this 10 blocks of memory for the variable a. Hence, so now a is going to point at the memory block which has been assigned or created. Fine. This is how the array is going to be created in your Java program. And one more important thing, so this two steps process what is going to be followed in Java is creating array variable and assigning the memory block for array variable can be done in one single statement. the two process combined to one step, but still this is two process again. I have just used the shortcut here, having int a, and I'm going to allocate the memory. So create the array, first step, allocate the memory, second step. Still I'm using the two-step process but putting in one single step. Whenever I talk about initialization, it is similar to single step what we are doing usually in C and C++. That is, we are going to have int a with empty blocks. We are going to assign 3 elements. Hence, the size of the array is going to be 3. Hence, if this is the case, you need not follow the two-step process. You need not follow. It can done with only one single step, because now I am assigning the variable, and your Java compiler knows you're trying to put 3 values or 3 elements into this Java. Now your Java will allocate 3 blocks of memory of the type integer and will be assigned to this variable array. This is something similar to your C and C++. The initialization is going to be similar to that. And so now, whenever you're going to talk about declaration in Java, as I have just mentioned these two ways, let's just look at this. When I say int a, now this is where I am declaring an array variable. The same can be done even in this way also. This I am going to have int empty brackets and a. Now a becomes an array variable again. Both are similar and the same statement. Now what is the advantage of doing this? So to know this advantage, look at these two statements now. When I say just int without empty brackets, now if I say an empty bracket comma b, yes, so as you are seeing, now this is going to be array variable, this is just going to be an integer variable. So now just look at this second way of doing this. Fine. So now I'm going to have the empty blocks for the integer itself, and so now whatever the variable you declare now becomes an array variable. Now a is an integer array, b is also an integer array, whereas that was not the case here. When a was array but b was an usual integer variable. Now this is what you can do in Java programming. If you want to declare multiple array variables in a same statement, you can use this style of declaration, which is not available in C and C++. Fine. And if I talk about initialization now, the initialization what we're going to have here is int, and I'm just going to have empty blocks. So a equals 12 comma 5 comma 4 comma b. So now I am just going to initialize the variable array variable a, but I am not initializing for the variable b, that is array variable b. Hence, so the memory for a is allocated for the but for the array variable b, the memory is not allocated. Now explicitly you need to execute the second step. That is, I am just going to have this statement as well as I am going to have this statement over here, because a will be assigned with the value 1254 as well as memory has been assigned. But for b, there is no initialization, hence we need to do it explicitly. Fine. So now this is what we're going to talk about initialization and the different way of declaring the single dimension array. Now just look at how the multi-dimension is declared and how it is going to be used. And when we are going to a multi-dimensional array, this is similar to this. I am going to have 2 empty blocks. I am going to have one size. I am going to give 2 sizes here, as usual what you have seen in your C and C++ program. Hence, when I have done this, I am going to have a 3 cross 4 matrix starting from the index value 0, 1, 2 for the row, 0, 1, 2, 3, 4 for the column. And so now I am just going to allocate the memory now. So once I am going to allocate the memory as int a in one single statement, instead of doing in 2 statements, I am going to do it in one single statement. That is what we are going to end with the same block of memory. But for just for explanation purpose, instead of having this as 0, 1, 2, now this should be called as a of 0, a of 1, a of 2, because array name is a. This is the first row, second row, and the row 3, and this are the columns. Hence, even I can represent these rows in the form of single dimension as a0, a of 1, and a of 2. And now, if I am just going to use if I'm going to use this style of statements, now each individual row can be allocated memory independently. Just look at this. In this statement, we are allocating the memory for the row and the column at a time. For all the rows, we are going to allocate the memory. But in Java, for each row, you can allocate the memory independently. Something like this. I'm going to have int a equals new int of 3. I'm defining 3 rows now. That is 3 a of 0, a of 1, a of 2. And the column is empty, hence it is going to point at null, something like this. I'm going to have 3 rows. Now all these 3 rows currently as 0 column, 0 column, 0 column, hence right now it is going to point at null. So now I'm going to allocate a memory for a of 0. The way I was doing here, a equals new. Now I am using a of 0 equals new. That is the first row of 4. Hence, the 4 blocks of memory will be allocated. And I can allocate for the second row as the 4 blocks. And I can allocate for the next row as the 4 blocks. So I can independently do it, or all together I can do this. But what is the advantage of doing this? Because I'm getting the same blocks of memory. So if you are keeping all the columns to be of same length, it's of no use. But just look at this example now. This example, so different rows is going to be of different lengths now. In the first row, I need 3 columns. Second row, I need 2 columns. In the third row, I need 4 columns. If this is the case, I am just going to make use of this style of execution of allocation of memory. This is what I'm going to end with the allocation. And this is how we need to handle the multi-dimensional array in your Java programming. Fine. And if I talk about initialization, it is similar to single dimension. The same way what you are doing all these days in C program. Use multiple pair of curly brackets. So first pair of curly brackets, the first row, the second row, and the row 3. Hence I'm going to have 3 pair of curly brackets separated with comma, and each curly bracket has got two values. And even I can do this. I'm just going to have 3 columns or 3 values for the first row, 1 value for the second row, and 2 values for the row 3. Hence I'm keeping it as empty. Or even I can keep both the blocks as empty and start initializing. So this is what array initialization in multi-dimension is going to be. And now this is going to be all about your arrays in your Java program. Fine. So thank you.